Hey guys, so today we are going to learn how to install a kill switch in any bike or a two-wheeler. Actually, this kill switch is being installed by the companies themselves in practically every bike that's coming out right now. Even scooties seem to have it. But for some reason, if you bought your bike from a cheapskate company like I did, so we have no choice but to install this premium feature by ourselves. So let us go ahead and learn how to install this kill switch properly in any two-wheeler. Before we actually install a kill switch, it is mandatory for us to know how an kill switch actually works. Because when I tried searching YouTube for fitting a kill switch in my bike, I came across so many wrong videos telling you all the wrong methods to do it. Some recommended cutting the ECU signal wire and whatnot. And please don't try those methods, because let me tell you from personal experience, in Bajaj bikes, at least this BS6 variants, it does quite the opposite. It actually ruins the engine's performance totally. It drops your mileage to a very low number, your self start will not work, and your check engine light will be on all the time. So they did the literal definition of a kill switch. It actually killed my engine nearly, and thank god I was able to revert it. And also, please do not try the methods that tell you to install the kill switch in the wires of the ignition keyhole, like the ones that you use to turn on the bike. So basically what that switch does is it also acts like a key. Like when you turn off the switch, it turns off the whole bike. So that is actually not how a kill switch is supposed to work. And also that method will only work if your bike is turned off, and when you're trying to turn on, it will not let the engine all turn on. While your bike is running, that switch is literally useless. It does nothing. So let me tell you how to properly install a kill switch in which it only turns off the engine and it keeps all the electronics turned on. That is the proper method. Let me tell you how it actually properly works, where we install it, how we install it. Okay, so to learn how a kill switch works, we have to learn how a petrol engine actually works. So there are three important components that are necessary for a petrol engine to work. That is the air fuel mixture, the spark component or the igniting component, and the third component is the exhaust of the gases. So basically what happens is air fuel mixture comes inside the engine. So after it comes in, the spark is ignited, which pushes the piston, and after it pushes, the exhaust gases, that's the gases that are burned off, is exhausted out. So what we are going to do is we are going to restrict the current that is going to come inside the spark plug right over here. Basically the spark plug gets current from the bike's ECU, like from somewhere. Imagine this is the wire that is coming into the spark plug. So it gets current to the ignition coil. So what the ignition coil does is it multiplies the current by 1,000 times, and it sends the current through thick wires to the spark plug, and that's how the spark plug gets the spark and it ignites the petrol or the air fuel mixture inside the cylinder. So what we are going to do is we are going to restrict the part where the ECU wire connects the ignition coil. So if we cut off this wire, there will be no flow of electricity through the ignition coil, and since there is no electricity to the ignition coil, there will be no flow of current to the spark plug. Therefore no spark will take place and the engine will stop running. So that's how we are going to stop the engine from running, and that's how a kill switch is actually supposed to work. Not by turning off the whole bike and all the electronics, but just turning off the engine by turning off the ignition part. So now that we know how a kill switch works, let us look at where we are actually going to install the kill switch. So this is our engine and this is the spark plug that is connected to our engine. So there are many spark plugs that can be present in an engine. You can only have one spark plug mostly in Honda bikes or Honda Splendor or any scooter, Activa, Axis. All of these bikes will have only one spark plug. But in case if you have Bajaj bikes with DTSI engines, they'll have dual spark plugs. So there will be twin spark. So if you have Pulsar and all, there are three spark plugs that are also there, but this video only covers mostly two. So the two spark plugs that will be there will be either side, one over here and one on that side. But if your bike only has one, it will be on the side or like on near the head or like somewhere in this side, in the front side I mean. So that's where the spark plug will be present. So as I've already told, this spark plug is actually connected to the ignition coil. So this white looking thing that is bolted using these two bolts is actually the ignition coil. Since Bajaj bike have two spark plugs, there are actually two. You can see one in the back over here and it is bolted over here. So there are two ignition coils and two spark plugs. You can see that there's something that's coming over here and connected over here. So since I've already done the kill switch modification, this is all my work here. Like you can see the red taping and everything. This is actually my work. So what it'll actually look like is basically just like one wire coming here and connected to this connector pin. This is what it will actually look like. Just one wire, single wire coming and connected to this place. Like that's it. That's how it will look like. So if your bike has only one spark plug, what you can do is just remove the connector and we'll just connect the kill switch like this. There will be a switch like that. I mean, this switch will be present on your handlebar, but we'll just remove the connector and connect one wire, and the wire coming from the switch will be connected here. And that's all. That's the one spark plug method. But if your bike has like two ignition coils like this, one over here and one over here, we'll use relays. So this is actually the relay. It is like this tiny, actually. It's so small. We'll have to solder the wires onto it. So it's pretty small. It's not like very small, but it is enough. Like it is kind of small. So it is easy to just put it over here. We'll just put the relay in between the connector and this connecting part of the ignition coil on both sides. This is for this ignition coil and this is for this ignition coil. So this is where we will be installing the kill switch wires, like between the ignition coil and the wire connecting to the ignition coil. This is the place where we'll be installing the kill switch wires. Okay, so now that we know where we are going to install the kill switch, we have to now see how many spark plug is present in our bike's engine, because based on that number, the method in which we'll use to install a kill switch will vary. To see how many spark plugs are present in our engine, we can easily do the most simplest thing, and it's very easy. I don't know if you have tried it, but you have to just look at the engine and you can see how many spark plug is present. But if you are like, no bro, I can't see, like, I got you, not an issue. I'll tell you how to actually find how many spark plugs are there if you want to verify it or you just want to try it out. Okay, to know how many spark plugs are there in a bike, what we're supposed to do is turn on your bike and come to the spark plug that you know exists in your bike. So what you're supposed to do is remove that, and you can see the spark plug inside. So after you have removed it, try starting your bike. So if your bike even starts after removing one spark plug, I mean the plug that connects to the spark plug, then it means your bike has more than one. For me, I know it has more than one, so it will start. So if your bike does not start, then it means it has only one. So in case if your bike is like mine and it has two spark plugs or even more, then go ahead and remove that one also. So, and now if I start it does not start. So now I know there are two spark plugs in my bike. Okay, so if your bike has only one spark plug or one ignition coil, so we are going to use this method. So what we are going to do is we are going to first go to the ignition coil. So as I told you from the previous part, this is the ignition coil. So this will be connected to the bikes by bolteds over here, like it will be bolted through here. So what we're going to do is we're going to remove the connector that is connecting this part. So imagine this is the connector that was connected. In my bike, it was covered by a rubber sleeve kind of thing. So we are going to remove this connector like this. Just like that, let's remove it. So after removing it, what we're supposed to do is either you cut out this pin, you can easily cut this pin and join and wire, extra wire through that, or you can do what I did. So what I did was basically I covered this whole thing with a wire and a bit of soldering. So I did that. You can either do that or you can cut it off, but since I don't like wire cutting, so I just covered the whole pin and like using cutting plier, I just tightened it pretty hard. So you can do that. And what we are supposed to do is we are going to take the wire that is coming from here, the wire that we tightened, and make it go to the one of the wires of the switches. So this is any kind of on-off switch you can use, but this is the ones that can be easily mounted to the bike. So we are going to connect one part of the wire to this part that is coming from the ECU. So this will be the wire coming from the ECU to the ignition coil. So what we have done is we have taken that wire and connected it to the switch. And the other lead that is coming from the switch, we are going to connect one more wire to it. And what we are going to do is we are going to connect one more wire to it. So we're going to connect one wire here and connect it to a new pin. So this is the pin. I have given link in the description where on how this pin will look like. It's an Amazon listing. You can just look at it and buy it from your local shop. It is actually pretty cheap. It costed me like 20 rupees or something. So you can just buy that, or you can buy it online. It is pretty costly, but it comes in packs of 100 like that. It's called a crimp pin or connector pin, anything you can call it. So connect it to that and just connect it to the ignition coil. So this way what will happen is, when this current is coming from the ECU to the ignition coil, or the current that is coming through the wire, it flows through the switch and then goes to the ignition coil. So if the switch is off, there will be no current that will be flowing through this orange wire, that this part. So the ignition coil will not get any electricity, and since there is no electricity, it does not send current to the spark plug that is connected here. And since no spark plug current, then there will be no spark or ignition. So the engine will stop running or not start if it is already stopped. So unless you turn this switch on, which allows the flow of electricity, it won't turn on. So this is the most easiest method of all the methods that I'm going to show. So this is the easiest method, and it does not affect any of your engine performance or anything. So that's it. Okay, so this is the method that we are going to use for bikes with more than one spark plug. So basically in this method, what we use is we use a relay. So a relay is nothing but an electronic switch. You know how a switch is used to control the flow of electricity. When a switch is off, it does not allow electricity to flow through it. And when a switch is on, it allows the flow of electricity through it. Basically, a relay is the same thing. It is an electronic switch. So we use electricity to control the flow of electricity. I know this sounds like a Christopher Nolan movie, like Inception, like electricity to control electricity, but it is very simple actually. So imagine this is the, not imagine, this is the relay. So you can see this is a relay. There are many voltage ratings of relay, like 5-volt relay, 12-volt relay, 9-volt relay, 24-volt relay. There are so many types of relays. Here we use a 12-volt relay because our bike's battery is 12-volt. So in the 12-volt relay, or any relay for that sense, there will be mostly 5 pins. So you can see there are 2 in a line over here and 3 in a line over here. So there will be 3 pins in a row and 2 pins in a row. Basically, these 2 pins are where we'll give supply to the relay. So if it's a 12-volt relay, we'll give 12-volt and ground to these pins. You can give it other way around also. You can give ground to this pin and 12-volt to this pin, not an issue. There is no positive negative for this relay, so it's not an issue. But these 2 pins are where we'll give the supply. So basically how a relay will operate is that whatever electricity you want to control. So if I want to control something, I give the wire to here. This is the supply wire that I want to control the electricity of. So let me make a darker color. So here, okay, so this is the wire I want to control. So what will happen is when this relay is turned off, what will happen is whatever electricity is flowing through this pin, it will go to this pin. So it will go to this pin and it will go to whatever it is connected. The electricity will not go to this side pin. The electricity will only go like this. So this is the normally closed pin, i.e. when no electricity is given, the current flows through this way. This is the condition that will happen when there is no supply is given to the relay. So in case there is supply given, in case if 12-volt and ground is given to this relay, what will happen is that whatever electric signal wire is connected here, the flow of electricity will be like this. It will go to this pin, and from here whatever is connected to here. So basically it is like an how train track switches work, like either I can make it go to this track or this track. Well, basically it is the same thing. I can either make this electricity go here by not giving any current to the relay, or make it go to this side by giving current to the relay. So this is how a relay works, and we are going to use this phenomena to control the ignition coil present in our bikes. So how many spark plugs are there in your bike will be equal to how many relays you use. So let me give you the wiring for if there are 2 spark plugs in your bike, this will be the wiring for you. So first you have to take ground from anywhere in your bike. You can take it from the battery, or your whole bike's metallic body itself is a ground. So what I did in my bike was that I just made the whole body a ground. Since it is a horn, I just connected ground to this pin and this pin. Whole anywhere from the body you can take, not at all an issue. And as I told, you can like vice versa of the pin. There is no positive negative, so you can give ground here, or anywhere. It's not a matter. But for the positive volt, what I did in my bike was, Since my bike is a BS6 variant, from BS6 onwards, Indian government says that they have to be LED DRL. So there is LED DRL that is present in my bike. So what I did was I used the positive wire, positive 12 volt wire coming to my LED DRL. I took a wire from that and I gave it to the relay. But in case you do, because I did that because it only gets electricity when the key is turned on and no electricity when key is turned off. That's why I use that. But in case your bike is very old and there is no LED DRL wire, or you don't know any wire that gets 12 volt only when the key is turned on, you can just directly take the plus 12 volt from your battery and give here. But in case there is no like LED DRL in here, this is the best method to do, because searching for a wire that only works when a key is turned on is pretty hard. So that method is not at all an issue. You can directly take from the battery and give. There will be no issues in that, because it will not drain the battery down, because it uses very less current to work. So not at all an issue. You can do that. But the best method and the proper method is that you take 12 volt from a line that gets electricity when the key is turned on, and when the key is turned off, it does not get electricity. So that is the most important thing that you have to take. So I took it from the LED DRL, so you can take it from anywhere. So the plus 12 volt line you have taken, what you're supposed to do is connect that wire to one of the wires in the switch. So let's connect it like this. And the other wire that is coming from the switch, take that wire and connect it to this pin of the relay. Same like that, do it for the other relay also. Do it like this. I connected the wire from the relay to the relay because the ignition coils are near to each other. So this was a very short wire was used, less wire was used instead of using it like this. Like instead of taking both from here, I just, I came here and then went here. It took less wire. So you can do the same thing. This is the best wiring part. So you can do the same thing. So now that we have connected the switch to this 12 volt, now you can control the relay using this on off switch. So when the switch is on, then the relay gets electricity. When the switch is off, relay will not get electricity. So this is what we'll do. So now the relay wiring of electricity is over. Now we have to connect the pins to this relay. So what you're supposed to do is take the wire, this connector, imagine this connector is connected to the ignition coil. If these two connectors are connected to the ignition coil, what you're supposed to do is just pull the connector, just pull it off and it will come out. So after you have pulled it out, what you're supposed to do is, I just removed a lot of wire from the sleeve and I properly connected it, and using cutting plier, I twisted it properly and nicely. And I took a wire from here. Just took a wire from here by connecting it properly and just connect it to this middle pin. Do the same thing to this pin also. So let's take the wire that is connected, let us make it properly nicely, and let's connect it to the middle pin over here. Let me do it properly here. Yeah. Okay, so I've connected to the middle pin properly. So this is what we have done. So what we are going to do now is, let us take this pin. So now we know that when the electricity is off, it will go out here. So let us take this pin and let us connect it to the crimp pins that we have bought. I've given link in the description for an Amazon listing of this pin. So you can see the image and buy it online itself, or you can show the image to your local electronic shop. They will definitely have it. You can buy it there. It's pretty cheap. It's like 20 rupees or 10 rupees. So you can connect it to this pin and connect this connector inside this ignition coil. So the same thing we are going to do for here also. So basically we'll take this wire, connect it to this pin and connect it to the ignition coil. And that's all. The whole wiring is done. You can actually cut off this pin, like using a wire stripper or wire cutter, just cut off this pin so that it is not poking anywhere. So this is the actual proper connection of wiring is over. So now let me explain how it actually works. So when there is no electricity flow given to this relay, i.e., when the switch is in off position, what will happen is the signal that is coming to this pin, okay, the signal that is coming to this pin and this pin, what will happen is the signal will go from here all the way to the middle pin. So the same thing will happen. The signal will come here and go to this middle pin. When the relay is off, we know that the pin signal from here will go to this pin. So it will go from here to here, and from here it will go to here, and so from here it will go to here, and from here it will go here because it is connected to the ignition coil. So when the switch is in off position, no supply is given to relay, so it allows the flow of electricity. So flow of electricity goes to the ignition coil, and when the ignition coil gets electricity, spark plug gets electricity. So spark plug will ignite, and therefore ignition takes place in the engine, and the engine will run. So this is what happens when the relay, when the switch is kept in off position. So when it is kept in on position, so imagine if it is kept in on position, now electricity is given to the relay. So when electricity is given to the relay, what will happen is the signal that is coming to this middle pin, right? The signal that is coming to the middle pin will go over here, right? The same thing will happen here also. Signal that is coming to this middle pin will go over here, but and then it will go here. But instead of going to the ignition coil, it goes to this pin, and this pin is not connected anywhere. So the ignition coil does not get any electricity. Here also no electricity is given. So the ignition will not get any signal from the ECU. So it will not get any electricity, and no spark plug will ignite. So since spark plug does not ignite, there will be no ignition in the engine, and the engine won't run. Or if it is in stop condition, it won't even start. So this is the actual proper wiring of a relay. A proper wiring of an kill switch using a relay. So this is the proper wiring. You can take a good look at it. So this is how you properly give the wiring. So this is the wiring that, as I told, most companies do, and even this is the wiring that I have given in my bike. But I have done the third method. I'll show the method after this. It is basically the same thing, but with an backup, so that in case the relays doesn't work, we'll use that method. Okay. So this is the third method. This is not a standalone method, but if you want to use it as a standalone method, it is not at all an issue, but I don't recommend it, as companies themselves don't use this method. I use this method as a bypass. So imagine if these relays stop working for some reason. If these relays will stop if these relays stop working for some reason, so we can use these switches to control the flow of electricity to the ignition coil. So basically, this is a bypass circuit. So in case relays don't work, we can use this as a bypass, and the ignition coil signal will go here and go here. Go to the ignition, the ECU connection will go to the ignition coil properly. So you can just install this switch itself, but I don't recommend it. I recommend using it as a bypass instead of a standalone part. But even if you want to do it, you can do it. So let me tell you how you install this bypass part. So basically what you're supposed to do is, you know how we took the signal from the ECU. This is the connector that we removed from this ignition coil. What you're supposed to do is connect one more wire on this pin and bring it all the way to this switch. So let me tell you what the switch is first. So this is a DP-DT switch. So basically what a DP-DT switch is, switches have two wire. If you turn it on, it allows flow of electricity. If you turn it off, it doesn't allow flow of electricity to these two wires. Basically what a DP-DT switch is when we were kids, like the light switches, we try to keep it in between, like keep it centered. Basically this DP-DT switch is our childhood dream. It actually does that. You can actually keep it centered without touching up or down. Like you can keep it in the middle position only. So how it is beneficial for us is, I'll tell you like while I'm doing the circuit. So just connect the wire from this. This is the ECU wire, the signal that was connected to the ignition coil. Connect a wire here and connect it to the middle part of this DP-DT switch. So you can see there are 3 in a row like this and like this, or 2, 2, 2. You can, however you consider it, but give it to one side of the middle pin. Do the same with this also. Here also do the same thing and connect it to this side of the middle pin. Let me do it nicely. So connect it to this side of the middle pin. So nicely make a connection here. You can either connect it from here itself, or you can connect it from here, from the relay itself. But since soldering is pretty hard in a tiny pin, I actually did this way. I connected it from here to here because that's a more easier way to do it. So you can connect it over there. So after you have given connection over there, what you're supposed to do it, and these pins can also, these connectors can also connect into this DP-DT switch. So you can buy more of this connector and just connect wires directly, and you can remove it also. It will be removable. So do that. So after you have connected to the center pins, you can either use the down bottom 2 pins or the pins on the top 2 pins, but make sure that this, so we are going to connect 2 more wires from these 2 or either these 2. not the other way around. Like you cannot use this one and this one, or this one and this one. You can't do that. Like you can't use this one and this one. So you can't do that. So what we're going to do now is I'm going to use the up part of the wire. So above part. So what I'm going to do is connect one more wire over here. So let me connect one more wire over here and take it all the way to this connector. And also here also take one more wire. So let me take one more wire, connect over here and take it all the way to this wire. Let me change the color. Let's do, yeah, okay. So let's take it all the way to this wire. So this connector. So basically what we have done is, so instead of using the relay, now the electricity can, if it wants, it can go to the switch and then go here. So basically what this DP-DT switch is, there are three positions in which you can keep this switch. First, let us talk about the middle position. So as I have given the photo over here, so you can see that when it is kept in the middle position, what will happen is the signal that is coming from this pin, i.e. both these pins, what will happen is it will go from here to this pin, right? That's what will happen. So it will go from here to here and then from here to here. So when electricity goes to this part, these two pins, and if you are kept it in the middle position, the current will not go to the bottom pin or the top pin. It will just stay there over here. It will not go anywhere. So at that point, whatever connection that you have given in the relay part will only be in the circuit. So your relay is now in the circuit and relay is going to control the electricity going to the ignition coil. So this is the standard position that we will keep the switch all the time. So it will be in the middle part. So if you have given a relay circuit. So when it is kept in the middle part, electricity does not go through the switch. Instead, it goes through only the relay. In case, if you press the switch downwards, i.e. the switch is pressed over here, the electricity will have ability to jump from this pin to this pin and this pin to this pin. It will not go cross. So no need to worry about it. Just make sure this pin and this pin is given in this way. Okay, so when electricity is given, when the switch is pressed over here bottom way, the switches in the middle and up will be in contact. So when these both are in contact, the current will be able to flow from here to here to here to here. The same thing will happen here also. So that's how this switch will work. In case a relay stops working, you can just press this switch like this and it will have a bypass way to just use this switch as a path to go to the ignition coil. In case you don't want the switch to work, or you don't want the switch to be in circuit, if you press it up, when you press it towards this pin, the electricity will actually go from here to here. Since these two pins are not connected to anything, the signal will not go to the ignition coil pin and it will not turn on. So basically you can just install this switch part alone without using any relay, 12 volt, anything. You can just use the signal wire coming to here, middle part, and from here to here. But the limitations are that there is only DP-DT switch. There is also triple, like there will be 3 rows also are available in the market, but these switches are not at all neat to install it, because as you can see, like they're like clip-ons. So you just clip these to the bike if you want. Like you have to make a hole in the panel of your bike's front part. It doesn't look good. And I haven't tried this alone. I have the relay and I use this as a bypass circuit. So it's a bypass actually for me. So it's not a standalone feature. I use it as an emergency feature, and I never had to actually use the emergency feature. But if you want to do it, you can just use it as a standalone, but it is not recommended. It is not what companies do. So that's all for all the 3 methods. Okay guys, so before the video ends, I just wanted to make one thing clear. It is that I didn't mislead you in the thumbnail. You know how I showed in the thumbnail that I converted this switch into this. So it actually kind of looks very similar, but with just one difference. So I don't want you to think that I misled you. I will actually now show you how to convert this switch into this switch. So basically, you can see that the kill switch in this kind of self-start switch will be over here. For example, this is the normal on-off switch that you can install in a bike. It will have 2 leads. This is an inbuilt switch that comes with the self-start switch itself.
So this will be the switch, and these two are the plugs that will work as same as these two plugs. So that's what will happen in this switch. So how to install this switch, that is how to install this switch, is that you have to satisfy two conditions for you to install this switch. Those are that first, your bike has to be from Bajaj. I know it sounds like why my bike has to be from Bajaj. Actually, your bike doesn't always have to be from Bajaj, but the thing is that this is actually an Bajaj Avenger 220 switch. So that's the reason mostly you can see a lot of Bajaj bikes like Platina CT 110X and so many Bajaj bikes will have the same self-start switch, except Pulsar series like Discover, Platina, all of them will have like either this or ones with ride control. So if you have all these switches, even though they are very similar and Bajaj is like kind of not doing much changes, it is actually a good thing for us. That is, we can we can cross match the switches and like use Avenger switch in any other Bajaj bike also if we wanted. So that is a good thing. Also, there is one benefit of using this switch instead of this one. That is that you know how this switch works, like it's actually kind of counterintuitive. Like for example, if you keep the switch in off position, the engine will actually run, like engine will be in running condition, and once you keep it in the on position, the engine will turn off. So it's kind of reverse, right? But what happens in this switch is it works in the like the symbols are drawn in the reverse manner itself. So when you keep the switch, like when you press the switch, that is if you keep it like this, it will actually on the engine, like it will keep the engine running. And once you put it in the off position or cut off position or kill position, it will actually off it, like it will work as expected, like as whatever is actually shown here is what it will work as. Instead, like over here it will be on off is written like kind of wrong, right? So that will be rectified. But you cannot install this switch in all the Bajaj bikes. For example, if your bike has this ride control, then I don't think you'll be able to install the switch. Either you have to remove this ride control whole thing and install a kill switch. By the time you're doing that, you can have to replace the whole thing. So either you have to give up your ride control switch, or you can use the same thing along with this switch. You can just install it to the side. It's not at all an issue. And there will be also one more difference. If you see, some of the Bajaj bikes will have three modes in light. For example, this is off condition of headlight, this is low beam of headlight, and this is high beam of headlight. You can do this. But newer bikes like my CT 110X only have two modes, that is off and on. My high beam is controlled as or using a switch on the other side. I actually don't know if this is low beam and high beam, but there will be three modes, and some bikes will only have two modes of light. It is pretty simple to like change it around, because if you have only two modes, there will be four leads. If you have three modes in the switch, you will have six leads. What you have to do is just use four of these pins instead of using all the six. Two of them will be empty. That's what I did in my bike. It was not at all an issue. I'll even show you in the demo video after this part, and it just works properly and without any issues. So if your bike has like the same design as this self-start switch looking thing, I've given a link in the description. You can buy that and totally replace the whole self-start part itself. But if your bike doesn't look like this, or your bike isn't from Bajaj, because I know this is a Bajaj Avenger 220 switch, so I know this will fit in other Bajaj bikes also, because that's what I've done. So if your bike is not from Bajaj, then you can just use another normal on-off switch, not at all an issue. So that's it.
Okay guys, so now let us see the final demo of the kill switch in action. So let me turn on my bike. So as you can see, this is our bike, and you can see that I've installed my kill switch. So what I did was, as I told, this was my stock self-start switch that came with the bike. But what I did was I removed this. You can see like they're like literally the same thing, with just one more step in the light. Like there are more steps, like look at this. 1 2 1 2. So instead it only has one. So that's the only difference, and it does nothing actually. It's now connected. It's the same thing, and like you can see there's a switch here, but there isn't. So apart from those two differences, it's literally the same switch. So you can actually use this method to install it in a Bajaj bike, and it's very easy and not an issue. So now let me show you the kill switch in action. So let me start my bike. There you go. And also you can see that I've installed my bypass switch, is what I call it. So you can see it is actually in the middle position. So these are the positions: up, middle, I'm sorry, up, middle and down. So the three positions are there for the switch. So it will always be in the middle position. So in case if you want to if you want to use without the kill switch, all you have to do is flip the switch to where you did not install the wire. For example, in this I have given above, you can see that there is no wire coming from this bottom part. I've actually given the wire on the top part. So I have to do it this way. It has to be opposite like this. And now if I turn on the bike, it's now, but if I keep it in the middle position, and now if I turn it off, it turns off. So that's it. So that's how it is supposed to work. And if I keep it in the above position, it actually basically does nothing. It will do nothing actually, because it's not connected to anything, and your kill switch is the only thing that will control it. So that's it. Bye bye. Okay guys, so that's it for the video. Let me know in the comments if you have any questions regarding the video. I'll try to explain it as much as I can. Also, if you stuck through the whole thing, thanks a lot, because I know the video was a bit too long and kind of mediocre, but I had to make this video at least for myself, because I couldn't find a proper video on how to install a kill switch in Bajaj. So that's the reason I actually made the video. Also, if you have any specific tech related questions or any electrical electronics like engineering related questions, let me know in the comments. I'll try to make a video on it, and if the question is too short, I guess I'll make a short on it. So I'll see you in another video. Bye bye.